My name is Mark Pelagian with Huntsman. I'm the tech service rep over here in New England. I'm out of Central Connecticut. I've been in the industry for about 20 years. As Don said, when it comes to any questions or anything spray foam like that, just give us a call. Don't be shy. Been with Huntsman for a couple of years now, and this has been a great company to work with. So,
yeah, we want to start off today by thanking a few people. So I want to thank Hal Smith with Halco. Doesn't look like he's in our room today. I think he might be in a presentation. Is that right? I want to thank Halco. They brought their spray foam rig here today. So after we're done with the presentation, actually this afternoon, they were kind enough to bring that out and showcase it for us. So those of you who aren't in high pressure foam or thinking about spray foam in general and want to see kind of a setup and what it looks like, they brought one of their hybrid rigs out. So our tech team here, Don and Mark, they will be out there and they'll walk through that rig a little bit, talk about some things, answer some questions on more on the technical side of things.
What do you mean by the term hybrid?
So they actually have a rig where they can spray foam and also blow in cellulose. So it's all in one. It's actually a really unique setup.
The hybrid's not high and low pressure options.
No. It's just high pressure and blown cellulose. So not just, and I'll be clear, not all rigs are like that. You know, high pressure rigs are like that. If you're familiar with that, I think you're with. Are you with Wise? Oh, you have a green shirt. Sorry, I thought you were. Okay. So they're not all the same. So they're a lot of them are just a high pressure rig. It might have 1 or 2 reactors on it. But anyways, they'll walk you through that and show you some of the features that they have on that truck as an option. So I also want to thank the BPCA, NYSERDA, for having us as well to let us talk about some spray foam today. During this presentation, if you guys have any questions, just like this gentleman up here did, feel free to ask. That's what we're here for. We're all trying to learn and to grow. Here's the other thing I wanted to talk about in the beginning of this presentation is if we don't know it, more than likely, we know a guy who does, right? We are one of the largest spray foam manufacturers in the world. So we have a lot of resources. If you ever heard the term, know a guy, well, we know a guy or two, right? So if we don't have the answer for you today, we definitely will get you the answer. There may be a lot of questions that get outside of spray foam that we'll be able to help you with one way or another. So I wanted to start off with a question today. Who here is familiar with spray foam? Almost everybody in the room from the looks of it. Yeah, good. So one of the things that we like to talk about, any spray foam presentation, I think one of the first things that people think about with spray foam is, you know, off-gassing, off-ratio, you know, nightmares, this and that. And I always try to remind people that, hey, we are surrounded by spray foam every day of our lives. You sit on a car seat. You know, we all drove here, right? You sit on a foam seat. Your couch is made of foam. Your pillow might be, you know, you have a memory foam pillow, memory foam mattress. If you take a chainsaw and you go down through your refrigerator, right down through the refrigerator, not that anybody would want to do that, but your food is surrounded by foam, right? So foam is a part of our lives. I mean, even automobiles, inside the car itself, BMW has a specific foam for sound. You know, that way the driver is quiet up to 3,000 RPMs, and then you can hear the engine because, you know, it's a more of a sport car. But foam is surrounding us each and every day with what we do. So it's not something to be afraid of. So antitrust statement, we're not going to talk about pricing here today. We're not going to talk about competitors or anything like that. Just something that we had to have in our presentation. So some of the things that we structured this presentation today more for some of the things that we heard back from NYSERDA, right? So they wanted to know about training. They wanted to know about the building envelope, air sealing, specific codes involving spray foam, off-gassing, safety, customer expectations, having a plan of action, And we also, one of the big things that, we're going to talk about today is the education piece of it, right? So we have here at Huntsman our HBSU, and I'm going to dive into that here in a second, but that's a huge resource to our company, right? So as questions come up or as things come up and you want to learn more about a specific topic, HBSU is a great resource that we have here. And that's really what, the main part of this presentation is about today is learning and growing. So you want to be successful in sales, you have to become an expert in it, right? Just like anything in life, you're trying to sell something, you want to know what you're talking about. And, in spray foam, I tell everybody, we're always learning, right? I mean, every day of the week, there's something comes up, or every week, a topic or something will come up that's like, hey, you know what? That's a good question. It's always evolving, it's changing. And the only way you can be an expert is to continue to learn. So we want to commit to learn and understand local building codes. So that's another one. You want to understand what's required, what NYSERDA is looking for, what the local building code is asking for. You also want to build relationships with insulation folks in your area, with code officials, HERS raters, energy auditors as well. So Huntsman Building Solutions University, adding value through education. HBSU, gets into a variety of different topics, right? It can be anywhere from tech services, anywhere from, hey, how do we sell spray foam, understanding building science engineering. There's a variety of different classes. So this is just an example of some of the classes that we do. So radon, unvented attic assemblies, which, by the way, I have a really good sell sheet or brochure out on the table for benefits of unvented attic assembly. The old way of thinking that a house or a home needs to breathe is old thinking or old knowledge, right? Just like back in the day, asbestos used to be a great insulation product. Well, guess what? Times have changed. Now people, instead of installing asbestos, they're taking it out and they're wearing hazardous, masks and suits and everything. So things change. A home no longer needs to breathe. It can be an unvented attic assembly. It's been proven that the home actually performs better that way. So I encourage you, if you're out by the table and you want to learn more about that, grab one of those and read up on it. So here's some of the other ones that we get into. Air barrier, acoustic. We talk about fire testing. We have a couple of different assemblies that are unique to Huntsman Building Solutions, W-Wall, D-Max, and air and vapor barrier is always a big one. I mean, the climate zones change with vapor barrier requirements. So there's a class out there for everyone, and we offer them both in English and Spanish. So if you have some Spanish-speaking workers working for you, then that's something that they can utilize as well. We have Spanish classes. So this is just an example of what a curriculum will look like for a typical class. There's breaks, there's a lunch break, all throughout the day. There's time, to answer calls and to do different things. But the biggest thing is these guys are familiar. They do it all the time. You can ask questions. I mean, it's just today's 2025, right? Everyone has a webcam. Everyone has FaceTime, Skype, all these different things. What's the same thing? You can be in your home or at your office and have your guys do a training with Huntsman Building Solutions, and they don't have to go anywhere. They can do everything. They can ask questions. Hey, Don, I got a question real quick. Yeah, no problem. What's your question? And they can answer it right there. And this is all things they can do right from the office. So if you have a day where it's slow, like, man, we'd really like to get some training done. Great thing to do on those slow days. So why are homeowners considering using spray foam? So I thought about this one, with NYSERDA, right? The idea behind this is, the big ones here, obviously building efficiency or energy efficiency, utility costs, right? But from a homeowner's viewpoint, especially in a NYSERDA situation where it might be a low income, they might be looking more for comfort, indoor air quality, building durability, some of the things that you can remind them of if you're talking to them, hey, this might be a great opportunity for you. the idea of a drafty house in the wintertime is not ideal, and it's something that insulation in general improves on, right? But more importantly, with spray foam and having an air barrier, can really help them improve on. So what is retrofit? Retrofit, we're going into an existing home, we're improving their insulation, whether it's the attic, in this case, a lot of times rim joists, basement walls, crawl spaces, and things that could possibly go wrong here. Obviously, we're going into someone's home, right? So there's always, the question of, hey, there's an odor, lingering odor, or health problem for the occupant. Incorrectly mixed chemicals, inconsistently applied spray foam, application of the wrong type of spray foam, installing open cell, for example, which is the half pound that doesn't have a vapor barrier, installing something like that in the wrong area where it's going to be taking on a lot of moisture. So just some of the things that we need to be aware of. We'll talk a little bit more too about other things in the house that we need to be aware of while we're there installing spray foam. So set the customer's expectations early. This was one of the topics that was brought up to us by the NYSERDA team, is having a plan of action ahead of time. So this one, honestly, this slide's really important because I don't know how many times I've talked to people. I've actually been on job sites myself where you show up and the homeowner doesn't want to leave, or there's pets in the house, or they're not concerned about reoccupancy times. You're not concerned about making sure having right ventilation there, right? So these are some of the things, covering and protecting areas leading to the spray areas. There's every one of these ones has come up, and I'm sure those of you that are in the room that have sprayed foam or have a spray foam company or work for a spray foam company have dealt with all of these. Your personal articles. I don't know how many times there's been, probably every week these guys, or every couple weeks anyways, they get a call about someone's personal belongings got overspray on them, And I think about these houses in New York, right? We have a lot of older houses where there's a lot of gaps and cracks and different things. You have to be very careful when you're spraying foam, right? Because if that gap or crack just so happens to, be an outside gap or crack where you could spray foam and it shoots out and it gets on the siding or something, or, it gets on someone's personal, grandma's, unique vase or something that's in a crawl space or something that nobody ever touched for years, right? It has a half-inch of dust on it, but all of a sudden it's important when it gets covered in spray foam. So just some of the things to think about. If we have time at the end, I think we'll talk a little bit more about some of the things that have happened that can be avoided and how they could be avoided at the end. So one of the things that we're looking for when we go into a home, existing home, what's the wiring look like? Is it knob and tube wiring? What's the ventilation look like? Bathroom fan vents. I can't tell you how many times bathroom fan vents that don't connect to the outside. They don't go to the eave. They're just exhausting right into the attic. And a lot of people don't understand what bathroom fan vent. Well, what happens when a lot of people get hot showers, right? What's happening with that hot steam that's being sucked out of the bathroom, and there's no exhaust to the outside. It's just going right up into the attic. But you can imagine what, in that case, what happens with that hot, wet air. Duct work, be aware of. Many times you talk to guys, hey, I went up in the attic, the duct work was apart, and I told the homeowner about it, did him a favor, put it back together. Obviously didn't want to spray foam on it. Be aware of environmental hazards, paint, chemical storage, flammables, and combustion, appliance ventilation. That's important. Don will talk about that one a little bit more later on. The condition of the roof deck. This has been a hot topic recently. Understanding that, spray foam doesn't fix a roof assembly, right? We have to remember that it's just an insulation. It doesn't, mind you, it's a very good insulation. It's very durable, racking strength, shearing strength with closed cell foam, but it doesn't fix the roof. And something that has come up here, been a hot topic recently in the UK, and I think it's trickled over into the United States, where they were spraying foam and expecting it to fix the roof when there were some clear issues. That's something to be aware of. If there's a leak before you spray foam, there's going to be a leak after you spray foam. It doesn't fix it. Retrofit planning considerations. So yeah, 100%. Odor is one of the most common problems associated with installing spray foam and retrofit. Why? Well, when you spray foam and you create an air barrier, right? A lot of times that air has nowhere to escape now. So if that homeowner had cans and cans of paint, or their cat decided to pee in the attic or pee in the crawl space, well, now you're trapping all of those fumes and all of those odors now, right? So a lot of times, especially with paint chemicals, that's something that comes up. Hey, I can smell some odors coming from that space now. Well, Mrs. Smith, you had a lot of paint cans, a lot of spray cans and acetone and different things that, maybe the lids weren't even on that tight. Well, now all those odors are in there, right? Because spray foam's just doing its job. It's sealing everything up and becoming an air barrier for the perimeter building envelope. So this is a kind of a mitigation pyramid about how do we mitigate the risk. So this is one of the biggest things. I mean, I think any point in history, you could probably point at, especially more modern days, of people being lawsuit happy, right? And so one of the things is you've got to make sure that you have a plan in place and that you're mitigating your risk. So you talk about the expectations up front. Hey, pets need to be out. You talk about what needs to be covered and protected. If you walk through the home and you walk through the garage and there's a brand new Corvette in the garage, it might be something that you might want to take note of. The other thing I wanted to say, especially with retrofit, is pictures, right? Lots and lots of pictures. You can never take enough pictures, because at least what things look like prior to you coming in, right? Because a lot of times things can change after you leave. And hey, I remember that was fine over there. Nobody knocked over your very expensive, once again, grandma's vase. But all of a sudden it's broke now, right? Reoccupancy times, something to communicate to the customer up front, having a process and a plan for your crews. And probably the most important one here is safety, right? Having the appropriate PPE.
What would you say you would tell people about leaving the house? There's a lot of different stories. How long to be out for? Overnight, it's 4 hours?
24 hours. Yeah, reoccupancy time for Huntsman Heat Lock for our product is 24 hours. Now, yeah, for the most part. It depends on the product, but for the most part, 24 hours is a standard for reoccupancy. Now, there are products out there that, and I'm not going to get into competitors and stuff, but you have to be careful. If it says that you can do it faster, you can do it in 2 hours, 4 hours, you have to make sure. A lot of times there is so much ventilation that's involved with that in order to get to that timing, that it's almost impossible to get it that much air exchange to get to that reoccupancy time. Does that make sense?
It might be 40 ACHs per hour. If you're doing an attic, that ends up being 15,000 cubic feet. You might need 8-10 fans to achieve that. And again, the issue is knowing the products, and a salesman might say, 1 and 2 hours, and then sell it like that. When you ventilate for 2 hours, it still smells. So we do run into knowing the product and what you can and can't do with it. And you'll see a little bit more on that further in the slides.
So some of the areas where, you can see the percentages here. So 25% can be energy lost through the roof, 35% through walls, 15% through floors, doors and windows, 15%. Obviously we're in existing homes, right? So it's not like we're going in and respraying the walls in the home. They're drywalled for the most part. So what we're trying to do here is, and going into an existing home, is trying to improve upon anything we can, right? So that's why we focus on crawl spaces, in this case, basement walls, attics, obviously anywhere we can improve the insulation. And the other thing is too, I mean, you're going in and you're insulating a home. So to be mindful of, hey, this window here that's cracked and there's air blowing through it, maybe that's something I bring up to the homeowner. Hey, this might be part of a big problem here, right? I had a customer one time. They said that they had a lady that her cat went in and out of the house. I guess it must have had a lower roof where there was a window. And I'll just tell the story real quick. But the lady would leave the window open in the wintertime all year long, really, for the cat to go in and out. So they got done insulating the house, and the lady was saying, "Yeah, it's great, but I don't think it's much better than what it was before." And their first comment was, "Well, do you close the window like when the cat goes out or when she comes?" No, I leave it open year round. Just make sure the cat can go in and out. So common sense, as Don here would say, a lot of times common sense is not so common. He's laughing because that's his go-to phrase, but it really isn't. So it's something you got to think about when you're walking through these homes. So the building envelope and the thermal envelope together are what makes things go around, right? So we have to make sure that the building envelope and the thermal envelope are in compliance with code. When we look at the climate zones I was talking about earlier, climate zones 1 through 4 don't require a vapor barrier, or climate zones 5 and up require a vapor barrier, right? So this isn't something like, for example, open cell. If we're going to use open cell in this situation, we need to have a vapor barrier, right? We can't do that here in New York. It's climate zone 5, in some areas climate zone 6. We have to make sure we're using the right products. We also have to make sure that, like I talked about with the roof, right? We can't have buildings that aren't structurally stable and go and spray foam and assume that we have a good building envelope and a good thermal envelope. It just doesn't make sense at that point. And essentially what could happen, and you see the list of the things at the bottom here, you could have wood rot, mold, structural issues, poor indoor air quality, obviously mold ties to that, higher energy bills. So just something to be aware of. I've had times, seen homes where the sunroom off the back of the house wasn't insulated properly, and you go and look at it, and there was something structural, with the way the sunroom was off the back of the house. There was no access to it, and nobody ever insulated it. So you have to be aware of the building envelope, what's there, what are you working with, and how can we insulate it properly. So understanding of the code. So who understands when to use a thermal barrier? Go ahead.
Typically, I was always told if you ever had any kind of electrical or anything like that, then you usually do your little area. That's what I was saying.
Space we use for storage or the use source.
That's it. Get them a prize.
Yeah, so anytime it's used for storage, that's 100%, 110%, it needs to have a thermal barrier. That's either product, the open cell or the closed cell, right? It's a code. It's not, it's not anything that we say, hey, it's just with our product. It's all products, all spray foam products are considered to be combustible. A code is a code. And so if it's only used for mechanicals, then it might require something called an ignition barrier, which a lot of spray foam products have an ignition barrier as part of their product, right? So these products here are Appendix X, ignition barrier free. So if this, for example, this wouldn't have storage in it, we wouldn't have to have a thermal barrier in this case. Is there any other questions on that? Any gray areas?
We'll get a little deeper into it as we go.
Okay. So air sealing. Summertime, the heat's trying to get in, right? Wintertime, the heat's trying to get out. So the idea is to stop the AC from running more frequently and stop the furnace from running more frequently. Essentially, with spray foam, the air sealing reduces the unwanted airflow, right? So with a fiberglass insulation type insulation, it's not an air barrier. You can take a piece of fiberglass and blow through it. With the spray foam, it has the air barrier. So that's the idea here. We're trying to stop the heat in the summertime and trying to hold the heat in the wintertime. So now we're going to switch gears a little bit to talk about existing homes with existing attic insulation. So we, as a standard, like to see the insulation removed. It's recommended, right? The existing insulation. This is an example of why that's important and why we feel it's important. This is an attic where there was blown insulation, blown in the attic floor, and they decided to go ahead and spray foam. But what happened was the insulation wasn't properly removed from the eave, right? So what happened was they sprayed foam. As you can see, what happened here, we have a hole or a gap to the outside. Now, what you did in this situation, you can see the smoke pencil on this side. What you did in this situation is now you're allowing air to pass through that area. So essentially, you have this really tight attic. It was just spray foam, beautiful spray foam. And now the eave is letting this warm air seep out, as you can see with the smoke pen. So what happens is now it's going to cause the eave of the home, you're going to start seeing ice build up on the eave in the gutters in that area. You may even see some moisture issues in the corner of that room. There's been times where it's been going on long enough where you might start to get some traces of water damage. So just something to think about when you're looking at existing insulation and seeing how are we going to tackle this. This is very important to watch out for things like this. So there's no such thing as a structure being too tight. The idea here, we're looking at system thinking. We're looking at how is the HVAC system sized. In an existing home, especially these, the homes we're working in New York, the idea is to help the HVAC system's ability to work better. That's the goal of air sealing. We're not trying to reinvent the wheel here. We're not trying to, come in and do a manual J on the house or anything like that. The idea is that we're just trying to improve, right? But so in this situation, that's the goal, right? Random leaks do not bring in fresh air. I mean, if you had, the best way I can explain this is that if you have, 5 windows open downstairs and 1 window open upstairs, you just have this air kind of going all over the place, right? So you have to seal the outside, right? You have to have the air barrier in order to help control the air movement. So like I said, in existing homes in the state of New York, the idea is to help your HVAC system's ability to work better. So another slide on why removing the insulation from the attic is important. The attic needs to communicate, right? So now you're turning the attic into a conditioned space. We're spraying the roof deck up along the top here. And before, this was an unconditioned space, right? Well, now that it's a conditioned space, we want this to be able to communicate properly. We're talking anything from airflow to humidity levels. You want everything. You want air to circulate properly. So by installing spray foam to the underside of the roof deck, it creates a semi-conditioned space. We want to ensure the air seal, that the structure is air sealing the structure as well. Existing insulation on the floor of the attic will impede the proper air seal at most critical entry point in the structure. And the idea here also is to reduce the odors, improve the air quality. So the manufacturer and the installer have an obligation to properly inform the customers about the properties of their product and the sustainability for different construction methods and end use applications. So the two options here, if you were to insulate the flat, which is something that comes up from time to time, insulate the attic floor, that's an option. And the other option is to insulate the roof deck. So when we're looking at this, the thermal envelope can't be ignored. We have to allow air and moisture to communicate. So this comes up. Go ahead.
It's a code question. If you spray the floor, do you have to use the energy code for floors versus? I know in New York State, that they have minimum primary roof decks, but it's lower than an open floor attics. So, the question is, there's the differentiator foam.
Yeah, I want to say it depends on the depth. It's a gray area. It depends on the home and it depends on the depth, because if it's for example, if you only have at the eave, you only have 10 inches, you know, it's like I said, it depends on the depth. For the most part, they want you to do it to code. But I have seen situations where you can insulate it less, depending on, like I said, the height of the attic, the eave itself. That plays into that.
There is also a performance method in the code where, they do a performance test on homes, find the R value of walls to attic to your HVAC. There's a way to, sometimes we see instead of all 49, you can all 38 in a roof. But, typically, conventionally, it is the code, unless you go the performance route. And that's utilizing, the envelope as a whole and calculating, the HVAC to our values within the walls and the ceiling. There is I think it's like 403 or 409. It's in the code on the performance side.
So in a situation like that, the problem in your state is that code varies by interpretation all over the place. So it's not one standard part of the state. So in a situation like that, are you further to, if not sure, invite your code person to weigh in before you give a quote? That way he doesn't flag you later.
Yeah, it's always that's always a good practice, right? But like Mike's saying, you go performance path, but you have to look at the code specifically, because there are areas where, like I said, depends on what kind of attic you're looking at and how it's structured, because there are clauses there where you can utilize less depth or less R value. So so we always recommend, if a customer doesn't want to remove the existing installation, I mean, really the point of this slide is, if the customer doesn't want you to do the job the way you feel it's supposed to be properly installed, then maybe that's not the job for you, right? I mean, everybody's dealt with a customer that's been difficult before. So sometimes it's best to walk away from those projects if it's going to be put you in a bad position.
Just to add a quick note, that I don't know if everybody this is common practices, but when you're opening insulation with slope, it's really, you need to take the fiberglass out of the flat. And I know everybody's on a budget and everybody's trying to win projects, but a lot of times if we don't see that connection communicating with each other in the occupied space, 9 out of 10 times it's because that attic flat wasn't vacuumed out and the insulation wasn't cleared out. It's just, you're creating almost like a vapor lock, by leaving that insulation in flat and then reestablishing it until the roof slopes. That's where where it comes to building science, that's where we see a lot of the problems. But it's, again, I understand that customers have budgets, but it's so important that it's something that's brought up to a homeowner that, we really need to. Fiberglass is an air filter. What's going to happen is your operator's going to go up there and he's going to spray foam. And what happens, what does an air filter do? Well, it traps air. So it can trap some of that, the exhaust from spraying the foam. And then when a customer calls you up 2 weeks later and says there's a smell, well, because probably those exhaust gases are trapped in that fiberglass in that flat. A lot of times you have you have plywood down that's nailed down and screwed down, and it's tough to get it out, but it's very important that you bring that up to the homeowners, because 9 out of 10 times if there's any issues, we walk into these guys and all of us walk into a home, it's because the existing insulation was never vacuumed out or removed.
Yeah, the other thing too is we talked about pet urine, mice, other things that were already in the insulation or buried in the insulation.
Right, very good point. We see that time and time again when there's feces and it was just never removed, and now all of a sudden homeowners got an odor complaint. Well, guess what? You just created the perfect air barrier. Now you're trapping all that scents and everything. Right before you had an open attic where you had air exchange. Now you have zero. It's a very little air exchange, and now those odors are trapped.
So this is just an example of some products at Off Gas. I mean, everybody loves the new car smell or the new carpet smell, right? So that's an example of off gassing. Mattresses, furniture, the big one, especially in retrofit homes, paint, all something to consider. But an odor is not always a sign of material off-gassing, right? So the new smell you experience when you bring new furniture home, or you apply a fresh coat of paint, is called off-gassing. Now, zero VOC does not mean zero emissions, or not necessarily even zero VOC. So, for example, the idea of reoccupancy after 24 hours, right? So the VOC equipment that tests, for VOC, or, to read VOC and determine if there's VOC present, after 24 hours is so minimal that it doesn't even register on the equipment itself. So, but that's just something to consider, right? You have to understand that there's never necessarily a zero VOC in a product. Trying to determine if a material is off-gassing based on scientific testing is problematic in a normal setting. Trying to determine anything for that matter in a home, hey, what's the issue? What do we think is causing the problems here? It could be anything. I mean, I've had so many, and we've all had so many different situations where somebody says, they immediately want to point fingers at the foam. It's a foam. 100%. You guys came in and did foam. It's a foam. And I'll just remind you, everyone here, that there's a lot to it. When you go in and you spray foam, and there's different products in the house, you have to be aware of that and understand that that's going to affect their smells, their new smells moving forward. I'm going to hand this over to Dawn. You want to work the clicker?
Yeah.
Okay.
So we're getting into a lot more what we see in the HBSU class, a lot of training on the systems that you're going to see. One big one is sealed and not sealed appliances. If we had that hot water heater and they want to build a room around it and insulate it, well, it needs certain ventilation. It's combustible. It needs the air to burn the fuel and the ventilation. So again, there are programs where they come in ahead of time, check the system you're going to use, and then check it afterwards to verify that everything's working properly, because you can create a huge issue. If everything's sealed, well, again, you can see combustible gases out, air in. That's not a problem. It's that little hood on your hot water heater that sits about 3 inches above the top that we need that ventilation for to make it work properly. Isolation, ventilation, and containment. Trade individuals are not occupants, so that's why they have re-entry and reoccupancy. Re-entry is for trained personnel, not people that live there 24/7. Even with foam, most other trades are not, they don't have the proper PPE, they don't know what they're getting into. So golden rule is just good 24 hours. That's the industry standard. And that's 24 hours after completion. If you start spraying at 8 in the morning, doesn't mean they should be back at 8 the next morning. It should be based 24 hours off of when you finish spraying. Again, occupants, office workers, homeowners, pets can't be inside the structure during application. Again, there are certain things that we build containment, and we have proper ventilation. There's things that we can do. If you have a big office building, you could block part of it. Make sure that you're sealed. Keep the pressure pushing the air the right way, and you could probably get away with something like that. But very careful. So we have office buildings, and they're going up above the drop ceiling. You don't know how far that can spread. So here's kind of what we were talking about. This is just a hypothetical. So they figured out with the attic, it would be 15,120 cubic feet per minute that you need to reach 40 ACHs, that's 40 air exchanges per hour. If you can achieve that while you're spraying, your re-entry and reoccupancy drops. But in order to do that, you would need to have 8+ fans running the whole time. And for the 2 hours after. 8 fans, most companies don't have 8 fans. If they do, where are you gonna get the power to run them all? You're not plugging 8 fans into your rig. So again, things are possible, but almost no one's gonna do that. Could we cut that attic in half with plastic and build walls? Yes, then it would be half as many fans. So there are workarounds for some things, but the rule is usually we want to clear everybody off the job site. Only qualified professionals should be there. This is showing you, let's say, the first floor of a building, windows and doors, air inlets, because what we're looking for is proper ventilation. So fresh air in, and then exhaust air out. We want to make sure that we're exhausting more than we're putting in, so that the airflow will travel the way we want it. What this picture is on the bottom here is usually when you have a ventilator fan, you have about a 20-foot accordion tube that hooks to it to run the air out. Now they make tubes, a big roll of tubing of plastic that you can cut to length. Let's say you had to run it 60 feet through the house. Well, they make things so you can do that. Especially if you don't have any, if you're in an attic and there's no windows. You might have to run it exhausted through the house. So kind of showing you our air inlet, our air exhaust, it basically creates a path. It's pulling all that contaminated air towards your exhaust zone. Then the next thing to worry about is where that air is ventilating to. You don't want it running outside next to a picnic table that the siders are eating lunch at. So it's all part of a system. So that whole area, because there's nothing stopping it, that whole floor is your containment zone. Because that gets into the difference between containment and spray zone. Less work if you're outside your containment zone, less PPE based on whatever hazards that you're dealing with. Big thing, especially in retrofit, shut down all HVAC. If you're in an attic and there's an inlet there and you spray and it pulls that mist in, it's going to distribute it through the whole house. Odds are it's going to coat the inside of the ductwork too. The smell will not go away. So instead of fixing the problem, you've actually created a bigger one. That could be changing ducts out. Again, like I said, that's a very expensive proposition if you do something wrong. So we shut down the HVAC, we seal any openings that we can. We be mindful of soft ducts. If you're dragging a hose across it and you rip the duct off the vent and you're spraying, now they can migrate into the house. And these are all things that happen. Mark and myself see a lot of different things that were very easily preventable. Number one rule in spray foam, if you don't want foam on it, cover it. If you really don't want foam on it, cover it twice. Especially in a scenario like this. So that's an attic staircase in the middle of the living room. That you would probably plastic the floor, run a ring of plastic upside, inside the access point, let it hang down, and then even cover your access point once you get up there and you have your hoses up there. Now, ventilation would help make sure nothing migrates into the house. So that's why ventilation is so important. We see tons of rigs that actually have fans on them, and when we get there, they're sitting in the truck instead of in the job site. We will let you know. We need to be using that fan. It's part of what we do. Big thing, again, we kind of touched on it, handling customers' articles. And you will lose this one. We always tell the story about the rocking chair, right? Rocking chair's in the attic, contractor says, don't worry, it's garbage. They spray, they get foam on it. They went to court and they lost. Value is subjective. But it came over on the Mayflower. Again, to me, it's a rocking chair. To them, it's a family heirloom. So be mindful. This is something we want to tackle before we get there. The salesman who was there first should have told them, listen, you have to get all this stuff out. Just number one, because the smoke can get absorbed. Number two, we can get overspray. Number three, it slows down the production. If we're moving stuff around, we're not spraying. So he said the common sense isn't as common. We have a better one. If it ain't spraying, it ain't paying. Every minute you're on that job and you're not pulling the trigger, you're losing money. So if this was already taken care of, have a plan. Like I said, the salesman that went in, and again, things change. It might have been clean when the salesman was there measuring, and they did that afterwards. It's just things we run into. But making the homeowner prepared for what you're about to come in and do is pivotal. Again, what we run into. In every rig, every trailer, every truck, there's holes that go through the floor. They might be to vent water. They might be to run lines, bolts to hold your machine down. And you have a leak in the truck and this happens. Well, you're probably paying to replace all that. So that job where you were making a profit just became a giant loser. Because we got ISO or resin on somebody's brand new driveway. It happens all the time. You can put in, when you pull up, you put something under it, a tarp. Something to catch it. This, like I said, we see it from 30,000 feet. We get these calls weekly. How do I get foam off of this? How do I get chemical off of that? The best thing to do is not to let it happen in the first place. That's just the way it is. You're going to have spills, you're going to have leaks. If we get preventative and proactive, we can avoid something like this. And usually it's a brand new driveway, it's a brand new house. Again, retrofit's a little different, but still, they just had a new driveway put in last year, and you've done chemical on it. It also opens you up to other things. OSHA, EPA, if there's a storm drain near it, you just have to be mindful of your surroundings. Again, heat emitting devices. We run into this quite a bit. Chimneys, flue pipes, corner fireplaces. Usually you can look up the manufacturer and read on how far they want you to stay away. A corner fireplace, if it's 6 inches away from the heat emitting device, it might change what you have to do. You might not be able to spray foam in that cabinet. So again, a lot of times we see mineral wool, rock salt, fire attenuation bat next to the heat emitting device, then we spray up to it. It gives us some R value, so it's not a wide open air chase. One thing they didn't put in is can lights. We stay 3 inches away from those. That's usually code. Even if they say IC rated. IC is insulation contact. That's conventional. That's fiberglass cellulose. Again, codes might be different depending on where you are. If you travel an hour to the job site, be mindful. It might be a different code zone. So again, if you can make the inspector your friend by being proactive, you're far better. Because the minute you have a problem with him, he remembers your name forever. Every job he goes to that he sees your truck at or your rig or you, he's looking for a problem. So you can't have a maximum service temperature over 180. Very rarely outside of flue pipes or something like that are insulated are you ever going to see that. I think I've seen it once and it was a wood kiln. They sprayed it. Oh, we'll never send it above 180. They did, and the foam stretched, so it all had to be replaced.
Real quick, one thing I wanted to mention was when you're talking about heat emitting devices, like say chimneys, sometimes you have a flue pipe that's, surrounded by the masonry, the brick and such. What you always want to do is you always want to put rock salt there because you have to verify that that substrate won't exceed 180 degrees. So when it comes to chimneys, even if it's surrounded by masonry, just do yourself the service and always put rock salt around it.
Because the burden of proof is on you. You're supposed to be. Go ahead.
So if you spray rim joists, for example, you have steam, you just 212 and higher, and you want to put some sort of intermediate foam in that.
Yes.
Yeah, they say anything that we think, because what will happen is foam being a plastic, it could either melt or it could start to smell. That's the worst thing. They think if they smell an odor, it's all the foam. So anything we can do to protect that, yes. If it's ever going to get above, if you even think it's going to get above 180, wrap it. Just protect yourself. Proactive.
We also have this product called High Heat that goes above 180 up to 240, 260. Something to be mindful to if you have a job where you're in an area where there is steam heat. A lot of times these big apartment buildings, complexes like that, where we have what's called a heat-lock high heat product that reaches higher temperatures in that kind of application.
So you be proactive and know what you need ahead of time to save you from a problem on the back end. That's the big thing with tech. Plan ahead. This is one we run into. So if you're doing intumescent coatings, thermal ignition barriers, which we'll go a little further into, we will get called out just for math 100 times a year and for odor complaints, and a lot of the time it's the paint, not the foam. Because now that you've made it a non-vented system, especially if you just sprayed it and all that heat's in the air and they try to go right back over and paint it right afterwards, it doesn't cure properly. If you're above 80% in that attic or wherever you're spraying the intumescent coating, it doesn't cure properly and it doesn't stop smelling until it cures. So again, you may have to go in and dehumidify along with ventilating. Reasons why it doesn't dry: too thick, cooler weather, applying excessive humidity, no ventilation, and the attic air is oversaturated. Again, these will not let the intumescent coating cure properly. Again, smell, or what we call spider webbing. It doesn't cure right and it starts to crack. It can even fall. So they start seeing that, they're going to call you back. This is what we do out in the field. This is, like I said, foam application temperatures and pressures can vary widely depending on a ton of different things. Temperature, so that's ambient and substrate, humidity, elevation, equipment, and other factors. So that's why we get into proper maintenance of your equipment. It starts with the equipment and your material storage before you ever think about spraying. But it all works in part of the system. While processing, they're saying watching the foam and adjusting temperatures, we call it reading the foam. An installer that's been spraying foam for a long time can read the foam, what it's doing, how long it takes to react. That's what chemistry is. It's not just heat and pressure, it's how long the timing takes for something to happen. It's the sole responsibility of the applicator to process and apply Huntsman Building Solutions products within specs. So again, that's why we go out in the field and do live fire trainings. We go out on the job site, see what they're doing in real time. Doing our trainings on the computer is one thing, but actually seeing how the installers are working on the ground can be a huge benefit. The safety and efficiency can breed profitability. Safety number one, down days, we don't want people to get hurt. But safety's number one at Huntsman. So if we show up and you're doing something wrong, we will definitely let you know. Nominal thickness, so we get into this more really in commercial. We do see it every once in a while. In residential, it's basically taking an average of depth. So 10 square feet, 9 depths. They plug it in to the chart, they do a whole bunch of them, and they average them out. So this came out to 5.12, that would pass. But when you get to residential, it's a little bit, it's right, but it's a little bit trickier because a homeowner doesn't want to see, well, these aren't too bad. A 4.55, homeowner's looking around, he sees a 4.5 inch depth on a 5-inch job, they might end up calling you. So residential gets into a little deeper depending, because it's their home, their single biggest investment. So we usually train to spray to your depth. Your low spot should be depth. That little bit extra they're getting keeps you from a callback. Because a callback destroys your profitability. You're going back for free. Plus, what about the job you could have been on that day? So you're actually losing 2 days.
Yeah, that's very important, especially as a lot of guys are putting this on their contracts, nominal thickness. I'm sure we've had customers where they go around and they're looking and looking, right? They want to get their money's worth. They'll put colored tape on all the areas that, maybe a 1/2 inch or a 1/4 inch high. But it's a nominal thickness, right? We take a huge 10 by 10 area and we do all the measurements and do an average. I can't tell you how many calls that I've gotten back because people thought they were getting robbed because we weren't spraying, or 3 inches and it was supposed to be 3 inches and it was 2 7/8. But what about a foot over to the left where it was 3.5 inches? So that's very important to understand this too, especially when it comes to.
We still run into it, like you said.
Yeah.
Even though you have nominal thickness, they want their 3 inches
Right.
everywhere. And if you have to go back again, you just lost a day.
And a high pressure application, it's impossible to get that dynamics. Especially when you guys are calling into these really contained areas and, barely getting an arm in there or a body. It's tight on a retrofit when you're climbing into these knee wall areas and low slope paddocks.
So here's when we get into, this is what Mark and myself and the other techs do out in the field. Open cell. So this 1/2 pound foam, T1 and T2. So anywhere between T1 and T2, you're making good foam. So sprayer spraying, it looks good. He cuts it open, it still looks good, but the difference is the chemistry. At the higher temperature, you're getting 18,000 board feet a set. At the lower temperature, you're getting 10. So you're making good foam, doing it right, but knowing how to process it optimally to get the most out of the barrel. Same truck, same guy. Again, this is part of HBSU. Same truck, same sprayer, same equipment, same everything. Wrong temperatures, and your yield changes. Closed cell, let's just say for math, 5,000 board feet a set. Sprayer's not spraying it at the right temperature, it gets 4,000. That's 1,000 board feet. That's 20% of what you should have got out of that barrel. Well, now you need another barrel to finish the job that you hadn't figured out. You have to go back because you didn't have enough material on the truck. So a lot of different things come into play when you're figuring the jobs. Not just what you're supposed to get and pricing, but what the installers are doing on site. Again, we know what T1 and T2 are because it does different stuff. If we spray it too hot, it overexpands and shrinks. If we spray it too cold, if you cut into it, you'll see a void behind the foam. So there are indicators of what goes on. Does the sprayer know that? That's when we come out in the field and train. We'll cut into the foam with a sprayer. Say, look at this. Does this look right to you? And train them on how they should be processing the foam properly and how to read it.
Yeah, the other thing that these guys can do is density checks. I know Joel and I were actually talking about that about an hour or so ago.
Yep.
That's something these guys can show you how to do too. So it's something that everyone, if you're spraying foam, you're in the high pressure game, something that you should know how to do.
Yep.
For sure.
So density check. So he was talking about the closed cells, 2 pound foam. So 2 pounds per cubic foot. We do a density check and it's 2.01. That's telling us you're processing correctly. If you weren't processing correctly, you wouldn't, your yield or your density would change. So a simple density check can give you an idea on how the crew is processing the material. Because as density goes up, yield goes down. So if we were spraying 2 pound foam and it's 2.5, you're definitely losing yield because the foam is denser than it should be. What we see, again, different things. If there's temperature on a wall, we can get blistering. If there's water, moisture, it's too humid. So that's blistering. This is cracking. If we spray it too thick, too fast, it generates so much heat, it can actually crack the foam so the heat can escape. This is where the sprayers are risking creating a fire. Like I said, if you ever see it, and someone's spraying into a garbage bag, stop them immediately. It's the biggest cause of rig fires, is spraying into a garbage bag. Because that closed cell might take 10, 12 hours before it self-ignites. When the rig's parked back at the shop, and you as an owner gets a call at midnight that your rig is on fire. It's something they sprayed into a bag at 8 in the morning. So again, you have to know what the foam will do. Every sprayer's run into this, a nice tight attic. Trying to get behind ductwork, it is what we do. We have to figure out a way. We do not what we affectionately call a spray and pray. We do not spray and hope it works. If we have a question, maybe we FLIR it. Give it a day, and then we use a FLIR gun to see if there's any air leakage. Do we find a different way? Spray down and then go out and pull the soffits. Sounds like a pain in the butt, right? It is. But if you don't seal the job properly, you're gonna have bigger problems down the road. We see jobs like this where, like I said, the first winter, there's ice dam. The shingles are getting pushed up because of the ice. It's because we couldn't get in there. And as installers, well, I'll just do what I can and I'm gonna go home. You're gonna create a problem. So we do, we come out and we train things like that. Is there things we can do to get to these tight areas? There's different ways to spray. We can flip the gun upside down in our hands so we can get more leverage lower. But you know, these slopes are rough.
Open cell.
Open cell?
Yeah.
That's a good one. Why? Because you can just keep pulling the trigger and it'll keep pushing itself. Closed cell, once it starts to react, it would create a barrier. You wouldn't be able to spray through. So again, sometimes things like this, you might just want to use open cell so you can drop the hammer and fill it up. So you can tailor your material to the job you're doing.
Yeah, you're still creating that air barrier, and then even off the job is proposed for closed cell. You know, once that open cell, you know, it's a lot easier to spray in these tight areas, and then you just go over it with 2 inches of closed cell, and then continue it up to the ridge. It's
So-
you have a dual reactor. It's a common practice with a lot of customers today.
The other thing to note is that you may not have open cell on your rig, right? So you have to adapt and overcome. But the difference between open cell and closed, so closed has depth restrictions, right? So you can only spray, and I often tell guys, try to keep it to 3 inches. 3 inches is a common one that I put out there. And then you can continue to spray more, but you have to let it cool, right? So in those situations where you don't have access to a different type of spray foam product, once again, you have to adapt and overcome.
Yeah. Or reach out. Again, you reach out to us. Mark and I have done all these multiple times because I can do like this and step through a 69 center stud, a 69 center cavity. So anything like that, I sprayed. It was part of what I did, crawl spaces, tight attics. There's ways to do things. What I would worry about here is trying to climb over that duct and laying on it. Once you compress a duct, you affect how the air flows. So we try to stay away from that. Something like this, we want to get in before the ductwork went in if we could. That would solve the problem.
And like Andy said earlier, that common term, we know a guy. There's a lot of things that we don't have the answer to, but there's a lot of years' experience in the Huntsman, and somebody's probably come across. As silly as it may seem to you, or it's really not. Some of these things are common, and somebody within our organization says, "Oh yeah, I had that happen in 1985 or whatever. I've been through it. This is how you do it to solve it." We're really. I try to sell. We sell kind of solutions, right? We're here not just to work for Huntsman. We're here to work for our customers. If we don't sell juice, we're not making money either. So that's no questions are dumb answer. Just reach out. No matter who you manufacture, just get friendly. There's always something. A lot of us came from the field. I came from the field. I had a gun in my hand for many years. Through the trades. So, a lot of us have a lot of experience, and we've been through a lot of things that may sound silly, but it's not so silly. There's an easy fix.
Yeah.
So it's a lot of solutions is what we try to help our customers out.
In tech service, with me, Mark, there's over 300 years of trigger time. If we need spray, you're spraying on the moon, or you're spraying something new. Submarines, naval ships, mine shafts, not just houses, and we use this to lift concrete. You lift a 5,000-pound piece of concrete to fall. It's pretty cool. Just don't overlift it. So we're getting to some of the things that we see out in the field. Roof overbuilds or vaults. That's where we have to kind of figure out what we have going on. So in this first one, they have probably just a dormer that sticks out. It's probably cosmetic. Well, we would talk to the homeowner there, you know, do you wanna go up there and spray that, or do you wanna seal it and leave it as cold space? Or it might depend on whether there's a window in there. We let the sun in, we can get a humidity problem. So knowing what we're spraying and what we're looking at is important, especially on the sales end. Know what we're gonna do before we get there. You know, do we have access? Can we block it off? Does it need to be ventilated? So all these things come into play. Again, if you were to call me with that question, I'd probably either put you to one of these guys, or they might transfer you to one of our building science people. You have the resources, we use them. Like I said, we can help you in that regard. So again, we're seeing a lot of what in the mobile homes, it's considered great insulation. Again, they usually are there's very little insulation in them. Usually the walls are light underneath. So moisture control being a big one. The benefits, superior insulation performance with an R value of 6 to 7. Again, the HFO high lift is 7.4, kind of. Reduce air leakage, minimize drafts, and improve energy efficiency. That's the point. That's what you're trying to do. Enhance moisture control and prevention of condensation issues. Like I said, that's not just for under trails, that's a lot of what foam is based on. Controlling your envelope. Because you're doing a lot of stuff. Chemistry. You're taking the materials, you're heating them, you're mixing them, you're putting them under pressure. Fluid dynamics. You got to get it from the barrel to the gun. Physics. Well, physics is what we figure when we're trying to figure out air movement. So the installers are doing a lot in the back of that truck. They might be doing it subconsciously, but they're doing it. IRC, IBC, again, we get into codes. A lot of this gets into prescriptive and non-prescriptive. So, again, it's thermal barrier. They're assuming that foam is a combustible material. It must be covered. It's got to keep the surface to less than 250 after 15 minutes of fire exposure. That's your 15 minutes of escape time if you're in a fire. Recognized thermal barrier coverings, half-inch gypsum. Nominal 3/8 plywood has been accepted for floors. This is where, in some applications, not directly connected to an occupied zone, where access is limited, you might be able to drop it down from a thermal barrier to an ignition barrier. You're always safer with a thermal barrier, but depending on the size of the project and what you're doing, that can become very costly. So again, understanding this, which we'll get a little more into, can help you determine how you're spraying your intumescent coatings. But again, codes, we have to follow them. That's why you have to know the codes in that area. If you travel 3 hours from your shop to do a job, you might be in a different code zone. You could actually be in a different climate zone. So just be mindful of where you're spraying. It's not what you do at home, it's what you do where that job is located. So again, it's about fire testing. So prescriptive, it's what's written. You can read it in the code. Having just word is written down. You can read it. Non-prescriptive is other things that we use, like a DC 315, but you have to have specific testing. So the no burn and the DC 315 are tested with all Huntsman materials. That doesn't mean you can use DC 315 on somebody else's material if it's not credentialed. If they didn't do the testing, I wouldn't do it. Like I said, with ours, DC 315 is approved with all our products for a thermal or ignition barrier, depending on thickness sprayed. What we run into is you spray in mils. You see, it says 18 wet mils. That's 18 thousandths of an inch. If the installers are putting it on like house paint, you're losing a ton of money. So out at the table, we have a mil gauge. It's how you can measure the thickness of the wet material. If you spray intumescent coating and you've never used a mil gauge, you've probably left money on the table. It's just the way it is. So this one, I don't think they put the sound in, because I tried last night. So this is what a thermal barrier does. So the first one's regular wood, the second one's painted wood, the third one has the intumescent coating on it, and they light it up. So just waiting for it to happen in about 6 minutes. You can already see it burning through the wood. The paint is emitting toxic fumes. That's what happens with a thermal barrier. It turns to charcoal and it lifts. It basically creates a shell around the foam so the flames can't get to it. And in this particular one, 45 minutes, they left it on. I think it'll show it. So you're seeing it burn through. I think, if I'm not mistaken, it's 45 minutes, right? After 45 minutes, you can still touch the back. They can show it. You can still touch the back of the piece of wood without burning yourself. That's what the thermal barrier does. It protects the foam. It gives you that time that you need to escape if you're in a fire.
So one thing to note about thermal barrier. So I've had the question asked before. Well, what if I wanted thermal barrier on my foam anyways? You know, and I'll put drywall over it. The idea of the thermal barrier, you just saw it there. It puffs up. So if you were to put that on, you know, say you spray foam and you spray to the face of the stud, then you put thermal barrier on, and you don't give that enough expansion room, then the thermal barrier actually will not work properly. So it's just something to note. If you're trying to use thermal barrier on something, just be aware that it has to have room to expand, otherwise it will not work properly.
So you spent the money, but you didn't get any gain out of it.
Right.
So the big question, again, in HBSU, we go a lot more into it, and we'll see a little bit more. Number one question, what is the space being used for? So there's caveats. Habitable space or storage. Homeowner says, we're not using it for either. If there's plywood on that floor, they're probably going to consider it storage. If there's a full stairwell going up to it, they're going to consider it storage or habitable. So just because they tell you they're not going to use it, that don't cover it. So if it's habitable or storage, you need a thermal barrier.
Oh, really?
Prescriptive, what is written in the code, what you can actually read. Half-inch sheetrock is one of them. Or you go non-prescriptive, but it must have specific testing. So like I said, DC 315, I think TBR No Burn, are both tested with every Huntsman product, so we know we can use them. So if we have a limited access space, let's say a small 2x2 hatch, and we go up, and again, there'll be a picture that we can look at. The only person that might go up there is a plumber, an electrician, fix a wire or check an HVAC unit for a drain problem. Limited access and no storage or habitable, you can drop that down to an ignition barrier. It's a little less protection. It just keeps the flame off the foam. It doesn't give you the full 15 minutes. But again, no one should be up there. Again, the closed cell foams are Appendix X, so if we did have an area where they thought you needed an ignition barrier, it's built in. Ignition barrier free end use configuration, that's a different type, and that depends on access. Usually you need to have a spring-loaded pull-down panel, a spring-loaded hatch, or a rock fond panel. These usually come into play when it's being engineered. An architect is doing it. It's for certain things we don't see it very often. I might see it once every couple of years, if that.
Yeah, sometimes.
So again, but knowing about it, so we do it in the HVSU. Again, the only question is, what is the space being used for? Habitable space or storage, or service of utilities? If it's habitable space or storage, or it has certain access, big, walk-up staircase, they're going to say it's habitable. Just do the thermal barrier. So again, we're seeing, it's a dead giveaway. Floor's covered, storage.
Well, that's organized, huh? Look at that.
It's a lot cleaner than most of the ones we went to. So we need to have a thermal barrier. We need to have 15 minutes of escape time. So here's one that we get into. So this is a parking garage. So we get calls sometimes about this. It's a parking garage. It's concrete. Do we need a thermal barrier? If there's going to be people in there, and there could be a fire, you need a thermal barrier. Then the second one we get. Well, you see some of these big pipes, there's sprinklers in there. Doesn't matter. There is no provision in the code that says if you have sprinklers, you don't need a thermal barrier. Just assume if there's any way, shape, or form that someone could be in there in a fire, you need a thermal barrier. This is rare when you get into more commercial work, industrial work. When you go in, you're foaming, you're talking about thermal barrier, and they say, no, well, we have thermal tiles, thermal barrier tiles. That still don't cut the mustard. Because what about the grid, the frame, and the wires that hang it? First one of those that gives away, and that first tile drops out, your thermal barrier is gone. So sometimes we have to check on these things. Again, okay, your tile. What about prove to me that the grid and all that are also? And they might not want to do that, and you don't get the job. But again, we saw the picture. Sometimes if the GC isn't giving you all the information, it's not doing it right, you really want to be on that job. Well, it's 200 sets of material, maybe. But again, these are things we need to figure out ahead of time. Because if you find that out later, and now you have to go back and all that grid and all those tiles are in, and you have to go back and spray a thermal barrier, your job just got a lot harder. So this is kind of what we're talking about. So we have an HVAC unit where we can see certain things. No plywood. Not storing anything up there if there's plywood. The other thing that would depend on this is probably the access point. How do we get into it? If it's small, 2x2, square that you have to put a ladder in to get up, it's going to be ignition barrier, not a thermal, because you're not storing anything. It's not habitable. But what we also get in this particular instance is we have other things that come into play. If you were going to spray this and talk about thermal barrier, so we need an ignition because it's not living, it's not storage, but other things come into play. So all this, remember we said the closed cell has an ignition barrier built in, so you wouldn't coat it with anything. Well, now we have a different problem, the windows. Anyone left a piece of foam out on the ground for a couple hours and then come out and see it turn yellow? That's UV degradation. The surface starts to degrade. Now it takes time, but in something like this, every window you'd see a streak. Wherever the sun went, you'd see a streak of yellow where it hit the foam. The surface becomes friable. It would take a long, long, long time for it to really get through the foam, but again, it's something that we have to consider. How long do you have to recoat with UV?
Typically 6 months.
So again, it's not going to do anything, but again, if you had to do something with that foam now, you'd probably have to scarf that layer off. If you wanted to paint it or you wanted to spray more foam, you'd have to scarf off that friable layer that built up so that the foam would adhere properly. Enclosed crawl spaces, again, kind of like what we were talking about. If there's no storage, obviously it's not living space, ignition barrier. So open cell crawl space, this again is kind of a debate that we get into about soil gases and moisture. What are you going to use in a crawl space? And again, over a career, we've done both. So the foam does what the foam does, but again, it's another thing to consider. What kind of moisture is in a crawl space? If it's all concrete, that's one thing, but if it's dirt, we're getting into other things that could happen down the road. So this is rare. This is so they're imagining a wall. This is the garage. These lines are actually up above the flat trusses. So they're talking about building a wall. So if storage, which I doubt, you're not going to use it for storage. But anyway, if above the garage was going to be used for storage, you got to build kind of a false wall. They're saying that you want whatever backer you use to spray has to be on the back side because you have to spray it with a thermal barrier, and thermal barrier must be in contact with the foam. So you would put whatever backer you're using on the back side of the red wall, spray to it, and then coat it. That's kind of what they're trying to get at with that. Very rare with a truss ceiling or you can get anything like that. No one's going to use it for storage, but again, that's a perfect time to call and ask a question. You call me, okay, well, I don't have a degree in engineering. I have a degree in trigger pulling. I can put you in touch with an engineer who can give you the paperwork and all that you would need. I know what it's going to do, but I don't have the credentials behind my name. So big. If you go onto our website, Huntsman Building Solutions, it's going to come up. It's going to say open cell, closed cell. You pick which material, then it goes into each individual material. So closed cell, you would see heat lock HFO. Gives you some basic information, and then right below it says product details. When you click that, you get this. So your SDS sheets should be on every rig. It's the safety data sheets. Technically, there should be an SDS for everything on your truck. You got a can of WD-40, there should be an SDS. You got a tube of caulk, there should be an SDS. From our point, usually people are more worried about the big giant 50-gallon drums of material that are sitting on the truck. So we make sure that we have those. You can have them, OSHA will allow them to be downloaded electronically on your phone, but you have to download them. If you have no internet service, you can't pull them up. The SDS, ton of information, transportation, medical, fire, tells them what to do in case there's a fire in the rig. Tells the doctors what they can and can't do if you, God forbid, get skin injected or get it on you. They're mandatory, office and truck. The TDS, the technical data sheet, has a bunch of stuff. Usually we consider those for the inspector. R value, density, some testing, some recommendations on pressures and temperatures. So that usually, like I said, the inspector wants it. There's, we're gonna skip over one, or over two, engineering and testing. Most of them have, a CCR, code compliance report. If you go to about page 5 in most of them, there's a chart. It's got your inches to R value. It's not a linear progression. So the 7.4 heat lock inch vote, actually at 1 inch is 6.8. But as it goes, your R values per inch go up. So again, it's not linear. So that chart can tell the inspector exactly what you need for the depth to hit your code. We go back. The best practices guide, or what we call the application guide, is for boots on the ground. If you're pulling a trigger, you should know that sheet. The first page has about 10 different materials that you're gonna spray on. Concrete, aluminum, steel, glass. They're all right there. It tells you might have to prime it. You might have to abrade it. You might have to scratch it up so the foam can adhere. Now, we have no problem taking that call. It's probably easier with 3 button pushes to pull up the application guide than it is to wait and talk to us. So again, knowing where to find the information that you need. A lot of it's right there. The website has a lot of brochures on it too, things like that about the material. Individual product and specific warranty, again, usually that's more engineering and architecture. As techs, we don't really deal with that much. And then, like I said, the engineering and testing documentation, big thing. Always follow all fire and building codes and equipment manufacturers' manuals, labels, and listings. Because what we do in the class, anyone seen one of these? Kind of hard to see. This comes with every gun. This we carry. This is in case you accidentally get a skin injection. At 1200 psi, that gun's against your skin. You pull the trigger with it open. It says it's scary. It's very easy to prevent. Most guns have trigger locks, but this says if injected, seek immediate surgical attention, not medical. Surgical. When you hold that gun in your hand, you treat it like there's a bullet in it. Because if you play around, someone can get very, very hurt. So like I said, it's safety. All of us carry these. So if something happens to us, they have the right information. And a lot of that is in your SDS, your safety data sheet.
I had a quick question.
Shoot.
Regarding the safety and the 24-hour clearing of the house for the occupants, is that more of a suggestion or a recommendation? In my capacity as work, as we help people navigate my sort of program, go through these things, where it's not consistent, people are told to leave their homes. And, you know, we get things like burning throats, eyes, stuff like that, because the contractor hasn't said anything. I'm just trying to figure out if that is a regulation or if it's more just something that can be suggested.
Yeah, it's a recommendation. Like I said, on our side of things, not non-NYSERDA, right? Just from the manufacturer, our recommendation is 24 hours.
Yeah.
That's when the safe, we see it as, like I said, I talked about the VOC equipment earlier, and it's the level of indication. It actually doesn't pick up anything after 24 hours. So that's why that's where the 24 hours comes from. That's the safest, what we see as the safest reoccupancy time.
Yeah, we've started talking to people about that, but we've noticed that that has been brought up oftentimes.
It's a protocol to kind of protect the contractor. I mean, like he showed you the screen where if you're on 8 fans at 12 hours, that you can create the ACH. Honestly, guys, nobody's using those fans.
Right.
Nobody has meters up on the wall of the attic to test the VOCs. It's very rare. We see it when it's a huge complex and it has to be mandated by the government and that municipality or from the owner of the facility. We just did a job Lower Hudson Valley where it was a big apartment complex of 55 and over communities with the crawl space where we set up a protocol like that where the guy had to have the drops with the slinky vents, everything had to be moved, there was meters, and it was set up in sections. So we didn't have to remove the occupants. Can something be engineered? Absolutely. Give us a call. If you have this particular project, especially something like that, in a large magnitude, call us up. We can help you prepare, a report and protocol for that.
So it falls in the category of a recommendation, not code, basically.
It is recommendation.
Yeah.
It's not something that's stamped, in the code or, but it's kind of just, again, everybody should be using the fans and just for the safety of your employees.
Yeah.
They should be moved in the air.
It's
So they, exhausting and pulling in fresh air. which is common practice
Yeah.
that we try to push for the industry. Because a lot of times when air isn't moved, what happens to that VOC? It gets trapped in somewhere, in shape or form. So the whole idea is you want to just, keep that air moving, because we all creating an envelope where we're sealing it. But I think, what happens, it's just, sometimes these things get trapped, or like you specified, something additional. There was an open can of ammonia or something in the attic or in a closet. I've seen it where there was a closet that was connected into the attic space. Well, nobody picked it up. And what happened? Well, those cleaning products, it kind of got, locked into the assembly. And that was a smell. Well, everybody gets to say it's the foam, and they get on the internet. And of course, you can find anything negative about any product out there in the world. So, and that's what you don't want is, uncomfortable. We want to make the customers feel secure. So we like be proactive, take a lot of pictures, take a lot of notes, and just preparation is 99% of it. Doing the application is kind of 1%, as I always say. So you want to try to eliminate a problem before it becomes one.
So we don't have a ton of time left. Dawn's going
So
to
we're gonna
speed
go
through these real quick.
Job site PPE for sprayers. It's usually well known: boots, chemical resistant gloves, suits, full face respirator that you might need fit testing for. There are loose fitting hoods. The one thing about this that we do for is this: someone coming onto the job, even a salesman in the company, and they walk in with no PPE on. Well, you just created a bad precedent. Everyone on that job site that sees that now thinks they can go in without PPE on. Everyone has to be on the same page. And he and I have done it. We're sitting there and the owner comes in or the salesman comes in and we tell him you gotta leave. And they look at us like, what? You don't have a respirator on. Get out. Set the precedent early. Control your work zone. Willful disregard. You let yourself get a picture taken with a guy standing on his head and there's a ladder in the picture. This is, like I said, if we see this, we're gonna have a little talk. Again, someone getting hurt is the worst thing. This is how we make a living. We want to make sure we get home to our families. So willful disregard is when an employee just ignores what they should be doing. Again, you see loss of reputation, legal costs, insurance costs. It's very expensive to be in the phone game, insurance-wise. Why make it worse with someone doing something foolish? Control the work environment. Oh, here's a good one. Let's move barrels and play around. No boots, no gloves. Again, me and him will have a huge problem with this. We ain't the phone police, but you're going to hear about it. You're 100% going to hear if we see this. Here's a worse one. Oh, I'm just pulling the trigger for a minute. I just want to show you guys how I spray. That's dumb. I apologize for being rude. That's stupid. That gas is going to hit that wall and blow right back in your face. You're literally setting yourself up to get sprayed in the face. So this doesn't look too bad, but it's wrong. There's several things wrong here. So, like I said, we go a lot more in depth to this on HBSU. One's right there. Unless we know he's got chemical resistant gloves under those, raw chemical can get on those and soak into the skin. Second one, usually we do this and we ask questions and make you guys answer, but you have time crunch. That. Number one, it's not chemical resistant. Number two, it's impeding the seal of the mask. The whole point of the mask is to seal to your skin. And he's got a head sock on with the mask hooked to that. He basically just completely, again, the air seal, you're letting potential for chemical exposure. So it doesn't look too bad, but it's still wrong. And we will point that out on a job site. So supplied air hood or respirator, chemical resistant coveralls, chemical resistant gloves. If we're ever coming to your job site and you're an installer, we don't find it funny when you're wearing Crocs. We see it all the time. Sprayers like to be comfortable, that's fine. But when you're walking on a plank 12 feet in the air, Crocs ain't the best thing to have on your feet. So when we come, again, we're not going to be the phone police, but we're going to let you know if we see something that we don't like. If it's that bad, we won't help it. We'll tell you either fix it or we leave. And usually we're there for either training or to fix something. You really don't want us to get in our truck and leave at 8:30 in the morning. Again, that's not only to keep you safe, that's to keep us safe. We're on that job site as well. Spray zone. So continuously working within proximity to the sprayer. Again, every company's responsible for their own safety program. That's not our job. That's your job as a company. The spray zone should be either supplied air respirator or supplied air hood. When you determine what your spray zone in, anyone outside of that can wear cartridges. But some people, whatever you want to do, I know that a sprayer is more efficient on air, period. They can spray longer, they can spray more. When you're wearing filters, even when you're running sport, you're the pump. And if you, 80-degree day in an attic, where it's 130, yeah, your day's gonna end quick. So this one's for you, bud.
Yep.
And a lot of this is out there.
Yeah, so this is just literature that we have out at the table based around retrofit installations. So stop out after this and grab some literature. So if an issue does arise, never ignore a homeowner, right? And the other thing I won't spend a bunch of time on this slide, but the other thing is cameras, right? So it's 2025. Everybody's got a Ring door camera or cameras inside the house, whatever, microphones. I can't tell you how many times, be mindful when you're walking through someone's home. Even if you have all the right intentions, just what you say and what you do, can and will be held against you if the homeowner decides to sue or something like that. You may have told somebody, hey, to go grab this or go grab that. I think we were just talking about it out here where, there was a situation where a homeowner actually clipped certain parts of what the person said and put it all together in video clips just to make it look like that person was trying to do something wrong, right? So just be aware of that. Well, and that's the end of our show. Appreciate everyone having us here today. I think we have like 2 minutes left. So if you have any questions, you can ask now. Any comments, questions, or you can.
You were starting off with foam, not foam, but use the 605 kits and so on. Is there any advantage to start with a low pressure spray foam system to start with to see if you actually like spraying foam?
I'll let you
You
answer that.
can, the difference is that with the low pressure, low pressure, it doesn't atomize as well. The gun is usually the one that has the helix in it. So that's what your mix is. On a regular high pressure system, you do a mix chamber. So the two side holes are all set, so it goes in and starts spinning.
Turn the lights on.
You get a better mix, better atomization. A lot of times you get less yield with a low pressure system because you're not getting that atomization. It's harder to make it look good because it's coming out more liquid than atomized. It will make foam if you keep track of it and you check it. It's less to get into, but if you want to go bigger, you're definitely going to move to a higher pressure machine. It's just volume-wise. If you're doing rim joists, like it might work for that. But if you decide to start doing cold basements or anything more than that, you'll probably need a higher pressure machine. They'll sound good and they work. But from what we've seen, if you're going to go to any kind of volume spraying, a high pressure system would be the way to go. Like to get better yield.
Yeah, and by the time you get done with the cost of a low pressure rig, it's like, you could probably get yourself into a high pressure system.
Because there are smaller units, so just for Graco has an E20. It's a smaller unit, smaller pumps, smaller heaters. Then you got an E30, an E40, an H50 for doing roofing.
Mm-hmm.
So you can gauge it according to what you do. There are other manufacturers out there that make smaller equipment. But again, a lot of it now is coming down to recordability and tracking. So a lot of the analog machines, the Gen 1 Gracos, PMCs don't have any of those computers. You can't track what you did. So it's your word versus whoever you're fighting with. With the Gen 2 Graco or an R3, it tracks everything. You can put a thumb drive into it. Tell you every 30 seconds what your temperatures were, what your pressures were, how much you sprayed. So it gives, as a company owner, it gives you that trackability. You can go on your computer and print out a ratio graph. They have ratio meters. So it tells you that you sprayed on ratio. So if someone says you sprayed off ratio foam, you can literally hit a button and prove what you did that day. That's the way it's going. Liability. He was touching on it. Mm-hmm. Everything's liability. If you can prove what you did for that day, you're far better off in the long run. But yes, a low pressure system would work for small jobs. But any kind of volume, you're going to want to go up to something a little bigger. Mm-hmm. Anything else? Like I said, we'll be out there. We're also going to be in the rig. I think after lunch, if you want to see how the rig works,